philosophy, no hands-on experience with biochar, just curiosity and gaps in knowledge that need to be filled, please.
Awesome.
Yeah, g'day Phil. Large garden and paddock amendments. I've had a couple of goes with biochar, digging a kiln in the ground.
Circulation and whatever. This bend here is just the heat. It's not a design thing. It's just a design flaw.
I thought that was a fine piece of
No,
engineering
next
there.
time reinforce the centers. And it's just got a water connection at the bottom, which is to fill water in and to get water out and that kind of thing. We can talk about that later as well. To operate it, and I'll talk about how we make charcoal in this open thing, like how would that make charcoal, right? It's what's called a flame curtain. So what protects the biomass from getting burnt with oxygen is the flame on the top. So we'll talk about it in a moment together with everyone. But what's important when we start it is to have a really strong fire right across the kiln. So to get that happening, just got a bit of cardboard and stuff like that here. So if we can break that and throw it kind of right through, and then we'll put a bit of brush on top, and then we'll start it all together in a moment. Yeah, so if you can help me just with that.
So is the idea of a strong fire across the bottom because you want an even...
I want to get an even spread, yes. I want to get an even spread. The oxygen is just right around us. If we do that, we end up with ash. We all had a fire. Now, when you start a bonfire outside in your backyard, you know how at the start, you see the flame kind of dancing above the wood with a bit of a gap? And then later on, it kind of comes down to it, and you start seeing white patches. You do know what I'm talking about? Right, so when it's above dancing, what's burning actually, what combusting, is the materials within the wood. So the wood is breaking, that's called pyrolysis. And the different resins and materials there that can gasify come out and burn on top of the wood. Now, that's what we want to do here. What happens when that's finished, the flame comes down into the wood, and what's burning is actually the carbon structure of the wood making ash, and these are the white patches. What we want to do is we want to burn all the internal material, like we said, create pyrolysis, but we don't want to let the carbon structure burn. So as soon as we see white patches in this kind of kiln, we're going to throw on top another layer of wood. And what's going to happen there is that wood is going to be in the heat. It's going to release its gases, which is going to ignite and burn on top. And that really strong fire at the top, what we call the flame curtain, will stop oxygen from getting through into the layer under. Does that make sense? And so as long as we maintain that fire up there, that flame curtain, then we have charcoal under it. And we keep building that, and we keep adding and adding and adding and adding until, and it keeps burning, right? So it keeps making charcoal, so it keeps dropping down. So from one bin of this kind of kiln, which is 2 cubic meters, we can probably put through a 10 cubic meter pile of wood, of biomass. And it just keeps breaking. And when it's full, or any time before, we can quench it and stop the process. So that's what we're going to do here. With this one, that's a TILA, top lit updraft. So it's got a few holes at the bottom, and it's filled with pine cones and sticks and stuff like that. And what happens, we start it at the top. We put this thing on top, we start the fire, and it starts burning downwards. And as it burns downwards, it gets heat coming down from air coming down from here. It's igniting. It can only partially combust. Oxygen, the gases come up, and then they ignite here at the top. And so it can't burn. I'm not going to go through the whole mechanical process, but it just, we put the lid, we let it burn, and when it reaches the bottom, it's all charcoal, and then we can quench it either with water or just close it with a lid, so there's no oxygen and just turns off. So these are the two kilns that we'll be using today. We'll get them both ready in just a second, and we'll start them both, and then we can split into the groups. Any specific questions?
What's your favorite?
It's just a matter of, there are different types of kilns again. It's really just a matter of application. So if I'm just doing stuff in my backyard, a few sticks or paper, cardboard, bones, anything like that goes in this kind of kiln. And we also have, I'm based at Pakaraka Permaculture, so we are up near Thames. We've got an organic market garden there, a chestnut and pecan orchard, and a few other things, and plenty of gorse. And so we use this scale on a farm scale. We take it around, we park it wherever, where we have piles of gorse or coppice wood or whatever. We process it there. And the benefit is that we don't need to cut the material too much. We can pretty much just throw it as it is into there and process a large amount fairly quickly. So it's just different uses. This one I've got at home, I've got a copper coil that goes into this chimney. It's connected to water and it fills my bath while I'm making. So it depends on the use. Other uses are, there is what's called a retort. So that's just a closed chamber. You throw your material in it and you heat it from outside. And so we've got heat, we've got fuel, but we haven't got oxygen. We pretty much bake it, you know, when you made something in your oven and forgot it there. That's the process. Yeah, and then there's other ways of doing it. You can dig a hole and do that kind of thing, but you can't move it around. So it's different. All right.
Okay.
Yeah.
The holes in the gallon drum, are they all at the bottom?
So there's holes at the bottom, and we're going to put this on top. And this got holes on the sides here.
Can we lean it back for everyone to have a look?
Yep. Careful on your hands with that sharp edge. Yeah, so you can see just holes at the bottom. I can give you all a paper, like a design of exactly how that works. There's a really clear paper, like document with all the details.
And Shekid, when you do your gorse, do you need it to dry first, or can you cut it green and throw it straight in?
Yeah, you want a strong fire. So you really want a strong fire, and you will have less emissions and better char when you use it dry. Once you get a strong fire, you can put in 70%, 80%, dry. But the drier it is, the better. So the cycle ends up being, you do your pruning, kind of winter, autumn kind of thing, right? And then you let it dry through summer, and then in autumn you make char. So that's how we use it.
Have your yearly bath.
Yeah. All right.
So, is there a difference in the quality of biochar based on those starting materials?
Yes. So it depends on the material. Is it hardwood? Is it soft? Is it hay? Is it paper? So the carbon structure that's in the material to start with is going to affect what it is, what biochar you end up with in the end. It also depends on the maximum heat you get to in the char process and for how long it is in that heat. And it also depends what you do with it after, how you quench it with water or without water, what do you mix it with, how do you do all of that kind of stuff. And just, we'll touch about it more, but it really, biochar is a soil, think about it as a structure, right? Not so much the minerals, the fertilizer that you give. It's not the nutrients themselves, it's the structure that will hold them. It changes your soil structure and does different things. We can talk about it, but so it really depends how we treat the biochar after as well for what it's going to do. I think the first bit what we can do is take some of that brush and place it in here so we're able to... Yes, as long as it doesn't block the air.
So in this, you don't want to sort of stack it forward in like that. You don't need to be
I just kind of look, okay, is there an area where we've got much and and I try and get it somewhat flat, so there's not too many areas in there.
Yeah, so laying the same way, sort of like
Laying down, so it's not just piled up, and then there's a lot of oxygen to be in it. Driftwood. Driftwood is fine. Driftwood, There's a question here about driftwood. So driftwood is high specific thing, right? You'd end up, because of the salts, you have high sodium, high chlorine, and things like that. So it's fine to use. You just need to be aware that that's what in your material. Is that what your soil needs? Eh?
You are adding a lot of PEC, so you should be able to manage it.
Yes. Yes.
Cows will love it.
Yep. Yeah, there's just a limit of how much sodium you want in your soils, right? So you can see how it will consume a lot of the material, right? We'll be able to add and add and add, and it just keeps coming down. And some of that bigger stuff will break down less, but still. And so I think something really important for everyone to keep in their mind is that, well, what I want to, maybe I'll say something about CEC. Is that a term that people are aware of? CEC? Cation exchange capacity.
Oh, yes.
So this is the ability of our soil to hold on to nutrients.
The microphone on?
All right, so what I want to just speak about quickly is CEC, cation exchange capacity, is our soil's ability to hold on to nutrients. As well, our soil has unique characteristics with how much moisture it can hold, how much oxygen it can hold, and so on. And so, if you think about your fridge, at home, if you think about your fridge, if you have a small fridge, you need to go to the supermarket often, right, to fill it up again. If you've got a big fridge, you need to go only once a month to fill up your fridge, and it saves you. This is the cation exchange capacity in a way in our soils. So if we are on sandy soils, which are very sandy, like water flushes through, nutrients flush through, so we need to add nutrients little and regular, right? If we have high CEC, high cation exchange capacity, and anion exchange capacity, then we can add the nutrients in, and then it stays there for a long time. We can add a larger amount, less often. So that helps, and when we add it in a way that makes it available to the plants on demand, then that's very effective. And we need to make sure that it's added in a way that's not going to just leach out. So that's why biochar is really effective, because one, it's got an enormous surface area. So a teaspoon of biochar is something like a soccer field of surface area. It's got high amount of cavities in different sizes, so they hold plenty of room for moisture and oxygen. And on that surface area, we develop organic compounds that hold to nutrients. So we've got nutrients, we've got oxygen, we've got moisture, and it becomes an amazing biota for microorganisms. And they can then survive better in the soil and so on. So what it gives us is the structure into our soil. Biochar, if done well, can stay for thousands of years in the soil, so we are amending our soil for thousands of years. We add biochar, we don't need to add it all the time. We add it once if we added the optimum amount, or we add little over a period, and then we end up with the amount we need. So it's hard to go too much. I was on sandy soil in Hawke's Bay, very sandy, and I added 10 kg of biochar every square meter in my backyard, in my home garden.
10 kilos.
10 kilos, that's a lot.
Yeah.
It's probably 30 liters. Charged.
What?
It's probably 30 liters chicken manure and things like that. And so the difference was enormous, because never mind the nutrients and so on, but the soil's ability to hold moisture totally shifted. So if you think about my 200 square meter garden, it's a good sized garden, but it's a home garden, and you times that by 10 kgs per square meter, so that's 2 tons of biochar in my garden. And each kg of biochar holds approximately 4 times its weight in moisture. I had 4 cubic meters of water in my soil reservoir, ready for the plants to suck in as they need.
And how much were you watering in the summer?
Yeah, so the amount of water you still need is the same, right? But you need to do it a lot less often, and the plants don't get stressed because it's there when they need it.
Yeah.
And it's not clogging up the soil like clay. Clay holds moisture, but it becomes spaggy, there's no oxygen. With the biochar, there's plenty of oxygen. So I added water, I added oxygen, and I added the structure that can feed the plants.
What's the best test you recommend for CEC, testing CEC?
A soil test.
A normal soil test.
Yeah, a proper soil test will give you cation exchange capacity.
Yeah.
Just a hell.
There was a good point there. You start, your different applications start fighting with each other. Do you put it through the chipper and make wood chip, which is very useful, or do you make biochar? And I think that what we do at home, we make both. Especially when I put in your chipper stuff that's usually more green, right? Because otherwise it's a bit hard on the chipper. So we do some amount of green into the chipper, some stuff we keep aside, and we make biochar from it. Also, it depends on the material. So you don't want to put, unless you've got a really big chipper, putting gauze through it is going to be a pain. So when you've got gnarly stuff, big branches going everywhere, you throw it in here. When you've got nice long stakes, you put them into your chipper. The thing is that with the chipped material, that's not adding to the carbon cycle, right? So it's very beneficial. It's called labile carbon, right? So this is available carbon. When we put compost into our soils, when there's biological activity in our soils, the microbes are consuming the sugars, the carbon, the nitrogen, and so on. So we are burning, the microorganisms are burning our soil carbon, releasing it into the atmosphere, which then is, in the atmosphere, we grow plants, it goes back into the cycle. And microorganisms need this carbon to grow and so on. We need that. At the same time, when we make biochar out of it, so we take that material, that carbon that's in the air, it grows into plants, we harvest it. Ideally, we harvest plants that died anyways, or that needed to be chopped anyways. Then we put it through biochar. Some of it burns, some of it is released back into the atmosphere, but it's not adding carbon because it's material that was just taken from plants, right? So it's a net zero cycle. But around 50%, we put into charcoal that then stays. So every time we do that, we end up with less carbon in the atmosphere and more carbon into the soil for thousands of years. So this is smoking, so it's likely that we really finished the burning there.
Put it out.
So we should put it out. What I want to do, we can do it with water, but I want to try and do it with just sealing the air. So we'll use the two bars, the two stuff. We'll carefully take that off, and then we'll seal it with a slate and clay. Yeah, just to get a perfect seal. Right. So if we put those through the top, and then we'll put it just right down here, right? Really slow, really slowly. Yeah. Okay, we can leave it like that.
They make them for people pre-roll with this.
My welding gloves are exactly like that.
Yeah, I can do that later.
And what I want to do on
so
top
when I'm
is just
firing, I
throw
start
some of
with
that
these,
clay.
and then I
We can
go
do
to
it by
welding
hand.
gloves. And I usually melt a pair of welding gloves each firing.
And just
The out the gun.
I melt that.
take that nail, don't burn yourself.
Each time I fire my kill.
Yeah, but in our home garden and the garden on the hill is way different.
So if you see smoke, just turn it up. I think it's done. The other thing we can do, yeah, or take those bricks out. Yeah. I will just, and maybe use a stick to, maybe this one, Yeah.
Another shovel for the 10 man. Yeah,
So there was a question about what's the difference when we quench it, when we what's called snuff it without water, to quenching with water. So it's two different uses really. So when we quench with water, which is what we're going to do here, what happens is that the water kind of shocks cool it, exactly like you see it, and creates a lot of steam. The steam goes right and kind of creates, it bursts the cells of the biochar particles. It breaks the cavities. It makes larger cavities, which is good, because larger microorganisms and roots can come in. And it makes the charcoal more hydrophilic, so it can absorb more water later on. Also, the water that will come out of it will be saturated in microcarbon particles, which is really good on its own. So if we can make the bin above our whatever garden or wherever you want to can use that water, then you open the tap after you filled it. You open the tap and you water that into your garden. So you end up with that carbon particles in the garden. It will have some amount of ash, right? So that's high alkalinity, which in most New Zealand soil, not all, but in most New Zealand soil, you want that because our soils are quite acidic, almost everywhere in New Zealand. So having that ash water, that lye water, is a good thing in most soils. Plus you get in the carbon particle. Dry means that you end up with a carbon material that's really strong and will soak up. It's like perfect for a filter. So if you wanted to use biochar for putting in waterways to soak up nitrogen and phosphate, if you wanted to use it for water filtration, if you wanted anything like that, having it dry, then that would be ideal. And
So you use that one more for like animals, for example. You know how people use biochar for poultry?
Yeah, both of them could be used.
Okay.
Both of them could be used for animal feed.
Yeah.
So one thing that many farmers are doing is you'd mix your biochar with molasses and feed that at 1% weight.
Why feed it with molasses?
Just so they want to eat it more, make it more palatable. At times, if they are deficient, they will eat it straight.
Yeah.
But at some point they won't, and if you want to feed it, then you might add molasses. At 1% weight, people say there's plenty of academic papers that show there's plenty of benefit. It increased meal production, increased health, increased weight gain, in chickens, like in poultry, in cows, in sheep, all of it. So it's quite effective. And the other benefit of it is that in our kind of grazing systems in New Zealand, we end up spreading the charcoal in our paddocks. Comes out activated, and then add to that, if we are lucky enough to have dung beetles, then the dung beetles will take that biochar up to a meter into the soil.
Right.
There's no many better ways to sequester carbon on large scales.
Yeah.
Do they use it or is it usable in like septic systems? You know, like you have a separate plant filled with it already in barrels?
Septic is to treat bio waste. Yeah, so we can help between biochar or charcoal and how do you call it? Biodigesters.
Oh, yeah.
Increase the speed of digestion by something like 10%. So that's quite useful in large-scale systems to increase the process, and the material at the end becomes more valuable.
How do they mill it? Because I bought some biochar from Auckland, it arrived in these huge 2-ton bales. But it's clearly been milled. It's all the particles of biochar.
So they have different material, either a ball mill or rock mills. You know, people who make fertilizer have got these big cone type things that turn around and break stones, you know. So they, in a backyard situation, it's a little bit harder, and you can choose not to break it. Put it into your soil, it will break over time. And some people put it on their driveway, on a tarp, and within a week of driving back and forth, in and out of your whatever, then it's broken pretty well. You can put it on a concrete pad like that and run over it with a roller. Different ways. Some people use a wood chipper. you get a blade that just for that, because it will blunt it. But if it's properly charred and not too much woody, you'd put it through a wood chipper. But you'll need to get a very good moisture level. Too little moisture, you'll end up with a cloud of biochar dust that you really don't want to breathe. And that's something to remind people. You don't want to breathe dry charcoal.
Is it sharp?
It's sharp and it's really bad for your lungs.
Right.
And so, but if it's too wet, it'll clog up. So you'll need to get the right moisture level. But people do that.
Presuming all your timber's the same, right, like same moisture content, what even does the kiln get it? You know, like you're saying you need...
It'll be fairly even, because a lot of the stuff, because it's in the kiln without oxygen, you can't really overcook it.
Okay, yeah.
Right?
Yeah.
Because as long as there's no oxygen, it's not going to burn. You can leave it there as long as you want.
Yeah. Yeah. So essentially right now, there's no fire in this part, in that lower part of the oven.
Yeah.
Of the kiln. Yeah.
Yeah. Thank you for maintaining this going. It's good to. So, as we said, the charcoal, the biochar is a structure, right? If we are going to take this charcoal and put it into our soils now, it is likely to slow the growth. Because it's not charged. So what it's likely to do is to grab, you know how charcoal filters, right? It's likely to grab a lot of the nutrients and make them less available to the plants for a while. So, and then within a while, microorganisms will grow in, you will have fungi and bacteria growing in there and making all this more available again, and you will see the benefit. So, what we do is not put it straight in, but charge it first. And when we say charge, people say activate it, people say charge. So we can do multiple things. Activate, when people say activated, what they mean is that they put compost tea or EM or whatever microbes on it that then help the process, make the process faster to grab nutrients and make them available a lot faster. The other element is we can charge it with nutrients. So we can put whatever is saturated in nutrients on that, and the biochar will soak it up, right? And we can do both. Ideally, we put in the nutrients and the microbes. So we activate it and charge it, and then when we put it into our soils, it's ready to go, and you see benefits straight away.
How good would worm pea be for that?
Yep. Worm pea is good because we'll do both. Worm pea is usually high in, depends what you put in the worm, of course, right? But high nitrogen, high potassium, not very much high in phosphate, and hardly any calcium. So you just want to have, however, the biochar will be fairly high in calcium. So we just want to think about what we put in our soils always, right? And what's lacking in our soils.
So what does the biochar have essentially?
So
Calcium.
the wood material that, if we're just using hardwood or different types of woods, is likely to have high levels of calcium, carbon of course, like we're talking 80% carbon, but then a high level of calcium and a bit less of that of potassium, maybe half of that of potassium. So if we're talking percentage, we'll talk about up to 20% calcium, 10% potassium, maybe 2% phosphate, some level of nitrogen, and then there'll be lesser and lesser amounts of all sorts of stuff, and it will depend on the plants where they grow.
So when
right?
you charge it, you charge
With what you want, with what you need.
do you put the EM in after you charge it with the other stuff first?
It depends how you do it. So it depends how you do it. So one way will be to mix it with compost.
Yeah.
Take that, mix it 10% volume in your compost. Perfect. The compost happens faster. It reaches higher temperature to start with. It holds more nutrients. A lot more of the nitrogen doesn't oxidize, just held in the biochar. So it will hold more moisture. It will have more carbon in it. It will finish faster and be better all compost. So that's a great way. So we do that at home. At home we also mix it in. We put it in the bedding of our poultry. So all their manure goes in and decomposes and so on. It reduces the acidic kind of smell, it reduces pathogens, and it's charging at the same time.
So you put it in...
Under the chickens.
Yeah.
We use composting toilets. So we put it in the composting toilets, right there. We feed it to the chickens, we feed it to cows.
The chickens eat it too.
Yeah, we mix it with our feed.
With the yummy stuff.
We mix it with our feed. Yeah, so we kind of think about our systems, our internal systems on the farm, and find ways to add the biochar in there. Yeah, and there'll be like a dairy that might be has effluent. They'll be perfect. Yeah, anything like that. Charge it first, put it into your soil after. And the best is if you can mix it into the root zone. So roots will grow right into it. If you can't, then you put it on the surface and the insects and worms and stuff will take it in. Or slowly we build soil on top in paddocks so it will get incorporated.
If you're spreading it, you're putting it over on the paddock using the surface application?
Yep. Yep.
And then, of course, if you're doing...
Or feed it to animals.
Do you mix it in mulch?
In wood chip kind of thing?
Yeah.
Yep. Yeah. Yeah. Mix it with mulch, which will mean it's on the surface.
Yeah.
But as we know, we put the mulch, it decomposes over time and will disappear, right?
Yeah.
With the charcoal, we're kind of making a surface level called compost, right? So we'll end up with the charcoal, we'll end up with the charcoal kind of interacting in the decomposition process. Yeah, perfect.
Check.
Perfect. Yep.
If you work with fresh manure, what about the pathogens in the fresh manure? Is not possible to load with them the charcoal?
Yes, it is possible. So it will depend on the application. It will depend on pathogens in the fresh manure.
Okay.
Yes. However, I have not heard about a situation where that was a problem.
What would you do?
So it depends what you mean by store.
Yeah.
So
To inoculate it later.
yeah, so if you want to store it, ideally store it not inoculated. Because once you inoculate it, you can, at that point, when there's pathogens, you can be growing pathogens and it's less, you know less what's the end
Yeah, so
result.
it's a waste.
Yeah,
Sitting there.
Yeah, and look, it won't disappear, it will stay there. But ideally, so if you want to store it, you're better off to store it dry. You want to be careful when you start thinking about storing biochar with a specific level of moisture. You can get self-ignition in large bulk bags. In the inside there is less dissipation of heat, and in the right level of moisture you can get a fire, and they'll be tricky. And so you want to be careful of storing large amounts. You want to be careful of how you do it and what level of moisture and so on. But you can store it. Just learn a little bit about what that means. I never had a problem at home. We usually empty that kill into fedges and waste feed bags or whatever, and it's perfectly fine. Yeah, it's not a problem really.
As long as it's dry, just store it dry.
Yeah, ideally store it dry. Look, we're gonna finish this, it'll be wet. It's fine. Really, it's fine, especially if you're in a home scale. If you're wanting to sell a product, you just need to develop some processes that are careful and that you know what your end product is like.
To dry it out, you could leave it out just in the sun.
You can leave it in the sun to dry. Yes, you can leave it in the sun to dry, but it becomes a tricky process. So ideally, I would put it in a process to inoculate it straight away, because that it's easier. It's wet. You can even mix stuff into the kiln and then put it in bags and let it inoculate. Let it do the process of in the bags, and then pass it on. There's different people operating. I could probably share with you
How
a few specific.
How would you inoculate if you weren't using liquid? Did you say you compost?
Like in compost, yeah.
It's very wet though.
If you wanted it perfectly dry,
Well,
it'll be,
you
you want
can't
the,
really sell it in a shop if it's wet.
well, if it's like a 50% moisture, it'll be perfectly fine. Or a bit less, yeah.
You said it's only 10% in the compost anyway, right? So it's not.
When
not a large
so it
volume.
depends what you're selling. If you're making compost, 10% by volume is ideal. If you're selling biochar, inoculated biochar,
Oh yeah.
right, there's a different product here.
So how long do you leave to inoculate?
It depends in what, but probably a month onwards. 3 weeks to a month will be fine. But if you're making compost, the process is longer anyways. But if you're just inoculating, you're talking about 3 weeks to a month.
So would you then inoculate and then charge it, you know, as in with other sort of fertilizer sort of components?
You could, but why wouldn't you do it at the same time?
I don't know, I was just curious.
You could, but we,
Do it all at once, yeah.
I never heard about someone doing that. People would just do it at the same time.
And you know the whole,
I think we should add more. It's hungry.
Oh, isn't it? I've read
So-
about it.
Usually what I would do at home, there's two options. One, I would quench it from the bottom, so I soak it from the bottom.
Geothermal bore.
And at the same time, I'll keep adding wood. So this is amazing pressure we put here.
Very unusual.
Not often you hear the amount of pressure coming in, so it would take time. And so I kind of estimate
How much do you want?
how long I still got, and I see that I'm running out of biomass. It's going to take me half an hour. I plug that in, and usually my kiln is full, right? So there's 2 cubic meters need to come in there. So I plug it in, maybe half an hour earlier, depends on my water flow. And I keep adding material on top, which means I don't have smoke because I'm keeping the fire strong. And then when the water really comes up to the top, I might pull that out and spray just the top quickly.
I'm on the roof.
And that's the process finished. And here we've got massive flow, so I can just let that go. We've got another hose there, we could spray it from the top. Sometimes, like I said before, I just throw compost, clay, lime on top in a layer and just snap it from the top and soak from the bottom, so I get partially charred clay compost mix, which is really, really good then to mix it in.
Would there be an advantage to doing that while in this process opposed to adding those things later?
Yes. So the partially charred compost has got its own diversity of extreme benefits of carbon structure and so on.
But what I'm saying is there a difference between putting it in while it's hot as opposed to mixing it after you cool?
Yes, because when I put it in the top, when I put the compost at the top, I actually partially charred it,
Ah, I see.
and that's it. Because the char process of the clay compost paramagnetic rock dust, when those are mixed together, or each on its own as well, partially charred, there's just multiple benefits in terms of carbon structures and so on.
But you would kill off all your microorganisms.
Yes, it's not going to be about the microbes. Yes, because people make char, we use prunings and so on, but we can make char out of hay, out of bones we talked about, out of manures, out of biosolids. All of those things have different characteristics, and with their own benefits.
When I die, can I become biochar instead of
People
ash?
are working on that in the US.
it makes way more sense to plant the tree on
Yeah,
top of it.
cremation with this.
Yeah, no, real. They call it biopod or something. Yeah.
What do they call it? Bio what?
Biopod?
Biopod or something. There was something like that. Yeah.
Yeah, biopod is a black soldier fly thing.
Become bio.
Yeah,
No,
but
no,
there is a
Homeopathic.
There was something like that.
1 gram. Yeah. Coming?
What do you think the flow is in this part?
How much water comes out of there? Well, it's coming from 100 meters up.
So with pressure.
It's got plenty of pressure, it's just the volume.
Yeah.
We filled it a third already, so.
Yes. It's A lot of water quickly.
Oh, here it comes. Look.
So you could just turn the water off and then burn further up. Carry on burning.
Yep. Yeah. You wouldn't want to go too far to cool it down, so you, yeah. And especially when, you know, I've got lesser flow at home, so I'd plug it in and keep burning for a while. And it just comes up with it. But look, there's not a lot of benefit. If you don't need to do it, there's not a lot of benefit because the charcoal under, it's in the heat, but it can't burn if it hasn't got oxygen. So it just waits there. And I just water the garden with it.
It's cooled it right off.
That's what I
Yeah.
want.
Yeah.
We need to collect that.
Can you put something at the bottom there?
Yeah,
We can.
want to, yeah.
Yeah, we can.
Yeah, I'll get Steve to do it all.
There's a lot of water in there.
Yeah, I know, that's okay. Well, Steve can figure out.
Yeah. You know how to
might
deal
take
with
him a
water.
minute though.
Yeah, we're not in a rush.
It's precious, precious.
It is.
Comes out of our hands. Yeah.
The water and the carbon.
Quite lumpy, how would you...
Right, so
What do you think? Yeah, a lot of toxins are going.
so a few things. So one, you say the water is actually quite clean.
Yeah.
If it's burnt well, my hands are never clean, so it's not an indication. But usually, if you put it on like that, if it washes really easily, then you know that you didn't leave a lot of resin in it and a lot of oils. You burnt those through. So that's kind of what you want.
Yeah, right.
And you can go as far as tasting it.
So some of the stuff didn't break down?
It hardly tastes.
It hardly tastes.
It hardly tastes, which is what you
Got a
want.
high pH.
It's got a high pH, but more than that, it doesn't got the oils. You don't want to smell. It does. You don't want it to smell too bad, and that because it's kind of the unburnt stuff.
So it should have no taste.
Yeah,
So it should be good for cleaning your teeth.
will be good for many things.
Even the bigger one, you say that's done.
So you just break that through. If that's perfectly fine. Yeah.
Yeah, so that was
There'll be some of that. There'll be some of that that we put probably at the top, and it wouldn't be fully burnt, fully baked like this. Yeah, so if it's strong like this, I know that it's not right through.
Save it for next time.
It's getting warm at the bottom.
That's fine. I know, it took me a bit to get it brave enough to do it. I was like, oh, I was watching to put my hand in it.
Yeah. So there's three stages in terms of temperature and what happens to the material. So when the biomass, or when the material is under 100 degrees,
It cleans your teeth.
we still have moisture in that, right? When we get to 100 degrees, the moisture is boils, right? It evaporates, it gasifies, and all the moisture is starting to leave, and it's going to stay at 100 degrees until that's finished, right? Until it's fully dried. And then between 100 to 300 degrees, it's what's called torrefication. So the wood is maintaining most of its molecular structure, but losing its larger structures. And you end up with those kind of, sometimes you find bits of wood that kind of, they look old, they're kind of brittle, but they've got their color kind of thing. So that's torrefied wood, and that's between 100 and 300 degrees. When the actual material goes above 300 degrees, that's when we finished pyrolysis, or pyrolysis happens, and that's where the actual molecular structure is changing or decomposing, and we end up with biochar or charcoal.
So 300 degrees.
Yes, so 300 degrees will be the minimum of the temperature of the material, the actual material, to actually get biochar, and then depends on the temperature what kind of biochar you will have. So the higher the temperature, the longer. So the biochar will break over time, like any material in the world, right? But the higher the temperature, when we're at 800 degrees, we're talking about biochar that would last thousands of years, while when we are in 300 degrees, we're talking about biochar that will last less. And so that just depends, and then temperature also affects biochar's ability to take on nutrients and moisture and those kind of things. So generally I aim for a higher temperature biochar, but it really depends.
There's some big chunks in there, so how
What you
are
want.
you going to get to do you grind it up, or what do you do with
Gonna
it?
give you a rake, Sarah?
You've got the rest of the day, right?
Yeah.
Or maybe the rest of the week.
So
You're gonna hop on there and
there's different. It really depends. It really depends on your context,
Yeah.
right? So we own, like I said, we own this kiln, 16 farms up the valley. Together, each family put $100, and we own it together, and we operate it together. And people, just chuck this on their driveway, and this, by the time a week goes past that you drove in and out, it's broken fairly well. I put it in our wood chipper, so it just runs through, and you end up with a thing coming out the other side. You want to get the moisture level right, because you don't want clouds of charcoal dust. Sometimes I would just put this in the compost as it is, and it breaks down more in the compost and then more in the soil.
If you were doing it ordinarily, though, you would have managed your wood application and size and everything a bit more than you've been able to.
I would, and
you
so that
probably
piece would have
wouldn't
been
end
more
up
broken.
things like that,
Yeah. But look, sometimes there are pieces and it's fine, like if I'm shoveling this, usually I'd tip it. So I'd open the water at some point, I'd collect the water if I'm in a place that I can do that. I let it sit for a little bit, I tip it, and from there I can, or depends what I'm doing, but I can shovel it into something, and if there's bits, I chuck them aside and they go in the next fire.
Does it make your soil look black? Or does that change?
I don't think so, because the amount, look, when I was putting, like I was saying, 10 kgs every square meter
Yeah.
in my garden, then you see that. When you're putting 1 kg a square meter, you don't see it as much. It's still there. The more it's broken, the more it's spread in that square meter. But you don't see it as much, it's still doing its work. Let's open this tank.
Yeah, let's open that one.
How hot is it? You still hot?
It's hot where somebody touches just Get you some more, mister.
It's hot, but it's not burning. Depends what it's down there.
Not heaps of this sort of down there. In places. We found a huge seam of it one day. We were burying a cow, and in early days before we realized we could compost it.
The question is, how hot is it in the middle? But we'll see. So,
If you open it too soon, is it finished in there? Maybe or maybe not. Huh?
so I'll explain again how this thing works. So this is what's called the TLAD, top lit up draft. And again, the way it works is that we've got some amount of holes at the bottom and 5 to 10 times more holes at the top, which is there. We fill it with material, we light it at the top. It creates flow with a chimney, it creates draft through the bottom, right through and into the top. Because there's not enough oxygen in what's called the primary intake, which is at the bottom, it can come through, it's only enough to initiate pyrolysis. So it means the wood structure is cracking, the gases are being released at the top here where we started the fire, where there is heat. That's releasing, but there's not enough oxygen for it to combust. So it rises up until it meets those holes, oxygen comes in and that burns. Now by the pyrolysis, the heat was happening here. Now because pyrolysis is an exothermic process, which means the decomposition or the breakdown of the wood structure releases energy more than it takes. So it releases energy, releases heat that initiates the pyrolysis of the layer just under it. Right? So that breaks down, that goes through pyrolysis, that breaks down, releases its gases, but not enough oxygen to actually ignite. So those gases flow up, they meet these holes, ignite, and we get clean beam. So we've got primary intake and secondary intake. So that keeps creeping down, and we've got what we call a pyrolysis front. So that keeps burning downwards, but leaving the charcoal above, because there's no oxygen enough to burn it. This draft is just enough for pyrolysis, not enough to ignite, Only when it gets to the top it burns. So it keeps creeping down, and it looks as if the flame is only here at the top, because that's where there's oxygen. It reaches the bottom, and at that point it can't go down, and it's finished pyrolysis. So the oxygen that comes in from the primary intake, from the bottom, hasn't got anything to, it doesn't get used, right? And so at that point it gets to the charcoal and starts burning it. Then you get flame inside. And so when we see that starting to happen, we quench it either with water or just by taking the bricks out and putting the lid and sealing, and then there's no more oxygen, so we know that we're not burning it. However, at that point, although it's hot, everything's already baked.
How do you know that it's burning from the bottom? How do you know that burns?
You will see. So you see, it changes. So when it's still pyrolyzing, gases are releasing, and they can ignite only at the top. So you see the flame kind of coming almost through those holes.
Yeah.
Because the oxygen is sucked in and it ignites as soon as it comes in there, and you see it burning inwards from those holes. When that's finished and it's starting to use the oxygen at the bottom to burn, you see the flame totally changes. The flame burns inside the drum, and you see it through the holes.
So it sort of starts snuffling itself.
You see through the holes. It will still be potentially a strong fire, but you see it's different.
Not coming out the top the same way.
Yeah, or not. It's not so much coming out, because when it burns properly, the flame doesn't come out. It comes in.
Yeah.
Because oxygen coming, right?
Yeah.
So when that changes, it's easy to see. You look through those holes and you see the flame not up here at the top, but just burning on top of the charcoal, and you know it's finished. And then you seal it or you water it. And at that point, it's fully baked.
And how long normally would you leave that before you'd open it?
I'd probably leave it for overnight.
Yeah.
And then I know tomorrow it's fully cold and there's nothing. There's a risk at the moment that if I open it, there's enough heat to ignite it again, which is not a big problem for us. We just put a bit of water on it. But if I wanted to keep it dry, I would just leave it overnight. You better try.
Do you always charge your biochar kit?
I always charge my biochar. I always charge my biochar because the benefit is so much larger.
What's your favorite charge?
Everything. It's in my composting toilet, it's under the chickens. I feed it, I put it in the bedding, I feed it to the animals, I put it in my compost, I put it in my wolf farms, I put it in my black soldier fly farm.
Yeah. Everything.
Everything.
Yeah.
Because it just adds benefit in every application. And I have it because I'm making it with the pruning from the chestnut and pecan orchards and from the gorse and so on. So I cut those things anyways. If I won't do that, I'll be chipping and burning them. The gorse will be burned for sure. No one will be chipping the gorse. So I work that I do anyways. That way I bring it into the nutrient cycle.
The difference between your deciduous and your evergreen woods? More highly resinous?
I don't know.
You don't care? You mix them up? And
I do mix them up. And generally what I hear in the science is that the diversity, like always, there's benefit in diversity, and that does apply in all the research that now, if you've got specific application and you want to design char with the specific characteristics, might be different. But
thank you.
Oh, look at that. Yeah. Charcoal.
Oh my God. Charcoal.
yeah,
That's perfect stuff. Would you say that's perfect?
that is perfect. At least at the top.
Yeah. Yeah.
But very light.
Yeah. Cool. Now.
Yeah. I bet I could throw those straight.
There was not enough airflow from the bottom.
Break up. Yeah.
And so kind of interlocking, too dense, interlocking, not allowing enough airflow.
But in saying that, the outcome is...
So what was happening, because there was not enough airflow, air was coming in from the top, coming in, igniting, and then releasing. But there was not enough. There was some air flow, obviously, and there was not enough air being able to come into this burning fluid. So I could see that happening, but it wasn't perfect. So we'll have a higher ash content in there, but yeah, we can tip it on something. Yeah, here, look.
Not burning.
So it's under baked.
About halfway, maybe halfway down.
Halfway down. So why would that would have been putting the lid on maybe too soon?
It's possible that I put the lid too soon, but I was also saying it started smoking, so that would have been two options. One, it reached the bottom, and there was not enough oxygen, and like pyrolysis reached the bottom, there was not enough oxygen, and it started smoking. Or the other option, which what I see is probably what happened, it burnt halfway, and then it was too tight.
Yeah, we thought
because there was not air from the bottom, but the charcoal on top also wasn't letting enough.
Yeah.
And then there was smoke, and then we're like, okay, we stop it.
Yeah.
So leaving it longer wouldn't have helped because there was no fire in there. So it's just polluting.
Right.
Take the material to another kiln.
Yeah. Take the top out and fluff it up a bit and do it again.
Yeah.
Yeah.
Are we going to tip this over or just
the residues?
We can. Yeah. We can tip it into something.
Danger of residues of resin in it.
Yes, but the resin doesn't need to be dangerous.
Okay.
So there will be, in the underbaked pine cones, there's definitely resin.
Yeah.
It doesn't necessarily need to be bad, it depends on the, yeah. Some of the resins and volatiles, when they are underbaked, are actually food for microorganisms. And so, for example, I know when Grant Patton, I don't know who knows Grant Patton from Environmental Fertilizers, he makes low temperature biochar by purpose in large piles. So he's got in this farm large piles, which he piles up with a tractor and ignites them and burns that slowly in low temperature. Purposefully, he ends up with some material that was in high temperature, some material that was in low temperature, some materials that's only torrefied, some materials that's fully baked, some material that's part baked with more resin in it, and mix it all together, and that gives him the diversity. The underside of it is that it's more polluting in the process of burning because there's a lot more smoke and that kind of thing.
And in that smoke, is there anything more than just carbon dioxide?
Yes.
What's the?
Yeah. So there'll be nitrous oxide, there'll be methane, there'll be stuff like that that's specifically worse than carbon dioxide.
But in the sense of like actually being toxic to organisms, or in the sense of just increasing carbon chain in the.
Yeah, and air pollution. You don't want to breathe that.
Yeah.
So we really want to be careful when we make large amount of biochar. We want to be careful of particulates, and particulates is a real problem. Like when we have particulates in specific sizes, people breathe it. We add loading into the air, and people breathe it. It's not good.
Yeah.
So we want to make charcoal. We want to make biochar in a way that's clean.
Are you staying away from certain woods, like avocado maybe?
I don't know. No, if you get into high enough temperature, it should be good. But maybe I don't know about avocado
like
specific.
Arsenic, or like any woods that are heavy metal accumulators.
Yeah. So you can assume that a material with heavy metals, the heavy metal will stay in the biochar. However, specific biochars have a capacity to hold on to heavy metals and lock them in a way, make them unavailable to plants. So in a way, that's a remediation way to lock away or clean specific areas. So
what's the basic on that? When you say specific biochar, what are you talking about?
So there could be biochars amended with specific minerals to increase their capacity to hold on to heavy metals. But just any biochar like that made with wood is going to do that, just to a lesser amount.
Oh yeah, like why everyone's on this fad of charcoal.
Yeah, they would do that kind of thing, just in a lesser amount of specifically designed charcoal.
But they are not available to plant roots. They are not longer available to plant roots. This is the reason.
The heavy metals.
The heavy metals.
Yeah, so some amount will be locked.
Yeah. And if you have a water filter with charcoal in it, you throw it away. But in the soil, you can't throw anything away. Now you have a certain amount only locked.
Yes. Now, unless you do proper tests, it'll be hard for you to guess how much of it is locked.
Okay.
Well, the biggest component of locking is pH. So if you have a low pH, it's going to be very variable. And if you have a high pH, it's completely insoluble.
Yeah.
So it's going to be locked to work. You keep your pH high, high 6s, maybe low 7s. Doesn't matter how much heavy metal you got there, it's not available.
Yeah. And the charcoal process will aid it, because if nothing else,
That'll tie it up.
if nothing else, the charcoal will have a liming effect on your soils. So even if it's not carbon exchange capacity that you need, if it's not anion exchange capacity, if it's not water holding capacity, just the liming effect sometimes is useful. Also, there are easier ways if you just need a lime.
But that votes also for diversity of woods. Don't just burn all avocado. You know, burn a diversity of woods, and you shouldn't have an excess of anything in there anyway.
Yes. And we think about our waste systems, right? Like I think that the best gain for buck is going to be when we have a waste system, a process that biochar becomes part of it. And that, you know, so I'm working, for example, with a Seagull Center in Thames, which is a resource recovery center. And recently we started a program of collecting food waste. So we are going to be using food waste with black soldier fly larvae. And then we are thinking about a process of using all the municipal grain waste to run through both chipping and biochar. And that get mixed with the food waste, and that's making compost, and that feeds back into the community. So we can incorporate those processes into our existing systems.
Hallelujah.
Ideally.
Why soldier fly and not worm?
And black soldier fly larvae are a lot more aggressive than worms, so they will consume the organic waste a lot faster. And the black soldier fly are the product themselves. So we end up reducing volume of the food waste by a lot, more than the worms, and we sell the soldier fly larvae as protein. Fish farms, poultry, pigs.
Your chickens love it.
Yeah.
But they don't survive the winter.
So we can talk about it separately, but we're going to start a big trial. Holding Fingers and Waste Minimization Fund, like the Ministry for the Environment, is going to give us a massive grant to run a trial with shipping containers that have a system of climate control. And so it's going to be done inside shipping containers. And then it's going to go year-round. And then it's modular. We can, if there's more, we add another shipping container. If we need to move it, we put it on a thing and we move it to another location. If there's roadblocks, it doesn't matter because it's flooded in the Coromandel. It doesn't matter. We can process on site. There's different benefits.
Have you ever left the big pile of biochar just there for 6 months or a year or anything and seen like big fungal growth in it or anything like that?
I have left biochar like that, and I have not seen fungal growth in it. And
That bucket's been sitting there for about 8 years.
I wouldn't think that you would see fungal growth because there's not usually depends, right? There's not the moisture and there's not necessarily the feed. There's not the available carbon and sugars that they would need. If you mixed it, yeah. So when I mix compost on top, when I snuff it with compost, and then come day after or 2 days after, and I mix that in and tip it over and let that sit, there's plenty of fungal growth in there.
Well, like actinomyces, like going hard then.
Especially if there's wood chip in there as well, and it just like interacts together.
What's next?
Yeah, I think you wanted to do a...
Okay, I'll do it now. I'm going to run just a little demo on our sprayer. Yesterday we poured that biochar in that bucket into the sprayer and sprayed it out, and didn't have any blockages, but did have a bit left in the bottom of bigger chunks that for some reason didn't get stuck in the puzzle. I'm tempted to throw a bunch of those pine cones in, but I think I'll wait. What I'll do, I'll just do a little demo, and then are you going to do a question and answer thing back inside at the end?
How do you do it?
What's that?
Do you take your nozzles out to spray it?
Have you seen my nozzle? 15 mil. I'll show you now. Yeah, we'll do that, and then we'll go back in, for a little wrap up and another question and answer. There's probably more questions now than answers. Yeah, just a synopsis for me. This seems like a perfect way to start for anybody interested in biochar. Seems like you've got a lot more control there. You can do a bunch of little batches and see how your mix goes, and then you can start doing some little trials, you know. And it seems like you've got more control here.
I'm not sure.
No?
Personally, I think that this is easier.
Oh, okay.
But it's large.
Yeah.
So not everyone's going to want to do that. But someone suggested the bath. People do that.
Yeah, bath.
Just a steel bath.
Yeah. Take your worms out first. Yeah.
Yes, a steel bath works perfectly fine for small amount. This is not hard. This is easy. You kind of just need to make it.
Yeah.
Which is not hard for you, obviously. And you just need to get it right in terms of just have enough airflow, but not too much air.
Yeah.
You don't want to have just like, you know, most of it air and it just all burns through.
Yeah. I can see
so you just want to get, after a couple of times, you get it right.
Okay, if you want to just come over here, we'll just do a little demo on that, then we'll go back and we've got to eat the rest of the food. Lovely job.
Are there any tests on glyphosate residue?
There would be, but I don't know. As in, if there was glyphosate residue in the biomass, how much of it is in the...
Now in the soil, and you apply biochar?
But I don't know.
Because there's a bad practice about this.
Thank you.
There's a bad practice about this in orchards. We kill with the glyphosate the microbiology, and then how to enhance life again. Stupid topic.
Yeah, it's hard, and it's always about feeding the soil, feeding the microbes, increasing the biological activity.
But I think it's about removing parts of the glyphosate in an energetical way. Still and I think there's something like a filtering process enhanced with the biochar. So it's not only a chemical direction, not only a chemical reaction, it's perhaps also, you say always, if I had a bad stomach, you use biochar. For humans with birch and so on.
Yes.
Yeah. And
headaches, like activated charcoal.
Yeah, and it's not only about the microbes.
Okay, maybe.
But it doesn't hurt anything.
Started from scratch, and we built one for ourselves. We had a field day.